Good morning, friends. Welcome to our channel. So today we are going to build something special. We are going to build a chessboard. In web, you have come across building chessboard, similar kind of examples in Java and stuff. They use inheritance, but today we are going to use composition, and we are going to build something interesting in Golang. As we all have come across that in inheritance, the chess pieces can be inherit the bishops, pawns, rooks, and knights can inherit the properties of the chess piece, and a chess piece can be set as a object. So we have already gone through that. So now we are going to do the same using composition principle. So what do we need to build a chessboard? Take your own time to think about it. So we need a chess piece, right? And a chessboard, and something that needs to be kept on the chessboard, that can be termed as movable. It can be anything. And the properties of the thing that is kept on the chessboard should match the properties that satisfies with the chess piece, right? So then only we can play the chess. We cannot like keep a random objects on the chessboard and play the chess. So we can let me start coding. Let me define a package main, and later let me import fmt. It will be much more clearer when I have a when I show you some sample struct. Let me first define the chess piece, that is the base, right? Type chess piece is, and it what all properties does it have? Come on, guys, guess it. Yes, chess piece contains the piece type and its color. It can be both black and white, right? We need to also differentiate the color, whether the chess piece belongs to white or it belongs to black. Okay, piece type, it will be string, and another one is color. It will be also string. So now we are going to define the like what are the methods that needs like that the chess pieces display. So the chess pieces needs to have the get color and get piece type. We need to define the getters. Um, so how do we inherit how do we use the chess piece and build functions over it? If syntax is goes like this. Hmm. Let me define the getters. String return cp dot color. We are returning its parent. This get color is inheriting the properties of the get color is defining the properties of this chess piece, and so we are returning the color of the chess piece. Similarly, we define the getters of the piece type. Same, we just copy and get piece type, piece type. So we have defined the chess structure of the chess piece and the methods, getter methods of it. Now we will define what we discussed earlier, like what that needs to be kept on the chessboard. Yes, it is a movable, whatever thing that is kept on the chessboard, those methods the those methods should be matching with this chess piece. So we define the same methods by defining an interface of the movables. I hope that you got the intuition behind why we need to define an interface movable. It contains get color, it returns string. Get piece type, it returns string. And what else needs to be defined in movable? Just think about it. There is a piece in on a chessboard, so we can also move it, right? From whether uh, move it, right? So we can define a move method that moves the chess piece from point A to point B. And if the move method is invalid, like the chess piece cannot move from point A to point B, then we return false. So we need to define the move method which returns a boolean value. Just call bool. So now we need to define the chessboard. Chessboard is like it is defined by 8 into 8 movables. As we have already discussed that whatever we are keeping on the chessboard is a movable board. Now we need to just initialize the chessboard. We need to write init functions. Function of it, new chessboard. It takes it does not take any parameter and returns an empty chessboard. So we also need to set the uh, chess pieces in this code itself. So first we will define a board and call the chessboard an empty board, and let's call another method that sets the chess pieces inside this board. Let the method name of the method be reset board, and again return this board. So basically we need to define this reset board method as well. Reset board inherits um, uses the chessboard and builds the pieces over it. So it takes the chessboard like it is a method of a chessboard board. We will define it later. Let's keep this for now. Mm, and what else methods do we need? For visualization purpose, we need a display board, right? Like we need to display all the pieces inside this chessboard. We just need to iterate every box, and we need to just return its color and its piece type. So so this is another function that we need, and another function that we need is move piece. So there is a chessboard. The move piece also is a property of a chessboard, right? So it is a like a generic method that that is used across the chessboard. We will define the piece specific chessboard move functions later. This is a move piece, like which every like after we define the piece specific moves. Like what do I mean by piece specific moves here? Like a pawn can move one step of from column 2 to column sorry, from row 2 to row 3, and it cannot move if there is any obstruction, and it can kill from if there is any piece of opposite color across its adjacent diagonal, then it can kill it. These are the pawn specific moves. So we are going to define a pawn specific move later, and that is going to use this generic move piece method that is getting defined in the chessboard. So move piece takes source row, src call, dst row, destination call, everything is int, right? What is this function going to do? Okay, this function, like if there is a this function is like a generic function, that all the pieces satisfy with, like movements of all the pieces satisfy it. Like give it a guess, what kind of functions, what kind of properties of movement does all the pieces have in common? So just give it a thought. I'm going to give away the answer. Like uh, if a if a chess piece is going to move from point A to point B, then um, if the point B also contains this any other chess piece of the same color, like it does not include the cases where the destination position contains the different chess piece type. For example, there is a black pawn that is moving one piece ahead of it, and there is a knight just ahead of it, and it is blocking, and it is of the same color. So this is a generic property that every chess piece follow. So we are going to define it here, and let's start defining the piece specific functions. Struct is going to inherit from chess piece. Later we need to define the move function, as we discussed. Move function, move method of the pawn. method of this pawn, like it contains the piece specific information and properties of the pawn. Similar move functions we need to define for every piece. So what does what are the core functionalities of the pawn? Like if the color is white, then and the destination row is source row minus one, and destination column is equal to source, like it can only move vertically and it can move one row. If this condition is satisfied, basically then we need to return true that yes, it can move from point A to point B. So let's just give up the basic code. If the color is white, then the row should be the destination row should be just one row above the source, and destination column should be the same as the source column. Return true. And the same similarly, else if the piece color is black, if destination row is one below the source column and it is in the same uh, column, then return true. Other than these two cases, anything we need to return false. So this is a pawn specific move method. So we need to define for all the chess pieces similarly. I think you got a broad understanding of how this can be implemented. So now I have already written this code for you. I will copy that code and show you how it works. So basically, I will just give a quick overview of this code again. So, we have left the reset board. Let's discuss it now. We are just in reset board. We are just initializing the board, like we are keeping the first column and sixth column as pawns of black and white respectively, and in the specific positions we are initializing the other pieces of white and black specifically. So this is going to handle the initialization of the board and display board, like we are going to iterate over every column and every row and get its color and piece type. So these I have also implemented some of the piece specific moves, like a bishop can only travel if the destination position and the source position is under the diagonal, and for also king can move only one piece, either it is left, either it is right, or any other direction. And the queen movement also have been defined here, and similarly the knight and the rook. So basically you get the code of basic raw code of every piece. Obviously uh, this code does not contain the logic, like whether of the attacking logic that you need to include. And in the main function I have defined the sample moves, like the source position and the destination position. Basically what it does is that it takes the piece from this position and keeps the same piece in this position. And we have stored that in a array of moves, and we are iterating over these moves and calling the move piece function. It is a generic, right? So let us the move piece function also contains the displaying logic. Just let me show you. Sorry. What I mean is that the board contains the displaying logic. So after every move, we are printing over the board, and later we are moving the piece of that board. So let me run it. Like this, these moves are like we are just keeping the pawn from first position to second position of the, like this. It is the board initially, and after the first movement, like we initially kept the black pawn to second position, right? So this is how it moved, and later. And that's it. So that's a broad understanding of the how a chessboard can be implemented in Golang. If you like the content, you can like not don't forget to like and subscribe. It took a quite amount of effort on building this content. Thank you.